Chilling, sitting here waiting for a class to start. Thinking about how am I gonna part this wisdom on the young ones. What we gonna do today? Gonna have fun, gonna play. Sitting here watching TV. Gotta let this student in. Oh, but he's missing his last name. I can't see. He just has his first name. Let me see what I can do, but keep it clean. Let him in the class so he can be a mean green. Let it. I almost. All right, guessed. Let's see. That was fun. We got exactly 1 minute. Okay, okay. Mm, 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 mm. Man, that would help if he had his last name. Okay, I think that's him. Let him in the class. He was going fast. He's here on time. He's real sublime. All right. All right. All right. All right. All right. So welcome YouTube, beautiful mind here, aka Professor Pfeiffer. I'm letting students in. So keep in mind, I do take attendance as I let you guys into the Zoom room. So as you get into my class, you've already got your attendance graded for the day. If you're in my Zoom call. Let's see. No real announcements. I am monitoring the chat if you have questions. The pace is a little bit fast right now, but once we get past chapter 1, we should be able to do like one section per class instead of 2. That's about the rhythm that we needed to do. I got to check and look at my lesson plans again. Again, if you have questions, feel free to either unmute yourself if anything is not clear, if you have a question, or feel free to type it into the chat. And so today, another thing. So this class runs from 6 to 7:15. Right now, I have the basic plan for Zoom, so I'm gonna have to end the call like about 40 minutes, and then I'm just gonna get right back on, and it'll give me another 40 minutes. So far, that seems like it worked. So I'm gonna do that going forward. So yeah, if there aren't any burning questions, I'm gonna go ahead and just kind of continue with where we left off. This is like the next section. So keep in mind, I pre-make video lectures for these concepts or these topics. So you'd have to go to my YouTube channel and watch the video lectures there. I try to limit it to about 35 minutes per section, so that way we can get 2 in. Let me see, right here we can get 2 in every session, at least for chapter 1. Okay, I can't think of anything else. So let's hop over to Pearson. And let's do like this. Okay. Who is this student? So yeah, if you're on the call, it is a good idea to have your full student name. Give me just a moment. Have your first and last name. That's a good idea, because otherwise it can be a little bit of a challenge. Go ahead. Go ahead. Can you hear me? Can you hear me? Yeah, we can hear. Yeah, I can hear you. Mm. So you go to my channel. There's a playlist that says it should say it's going to be one of my more recent lectures, because for you all, I'm making it pretty much every week. So like, there's a playlist, and it should be in sequential order. For instance, today we're doing section 1.5, so that had to be either 1.3 or 1.4. But the titles should be there, and it should all be in a sequential playlist. Another thing is, yes, no worries. As you're making your way through the homework, make use of the Ask My Instructor. It'll send me a screenshot of your question, and it's probably a good idea to probably link up with the tutors and your classmates. I know that some students started a group me, but yeah. Okay. Yep, no worries. Okay, so let's get the party started. Okay, so there are about two sections today. I guess when the timer runs out, I'll just use that as a natural transition to go to section 1.6. So 1.5, I think, is Leibniz notation and the power and some difference rules. Okay, so what we're getting into today, we're going to be applying the shortcuts for differentiation. So before we had the limit definition of the difference quotient, and that's a bit much. I mean, it comes out of college algebra. Let me let the student in. Should have kept that window open. Okay. Right here. Cool beans. Looking good. Admit. Um, so you know the limit definition. So again, the idea. Let's hop over to the tablet. Hopefully this doesn't make it worse. I'm going to do my best to try to be as clear and concise with this. Oh no! What did I hit? I don't want that. Go back. Go back. Come on. Okay. I'm going to let that be. Let's go here. And I need this to hop over to here. Cool beans. Nope, not there. I needed to go here. Okay. Did I lose my page? It surely looks like I lost my page. Heck on it. Okay, that's okay. I'll hop back over there in a moment. Let's go like this. Paper. So the idea of what's going on here, if I can, I'll do the best I can to be concise. So say we consider the coordinate axis, right? We got the y-axis. And let's do one more thing. So we have the y-axis. Tag on it. You know, this is the positive y direction. Say we have the x-axis. Here's the positive x direction. And say we consider some curve, right? We're just considering some general curve, right? So then we consider a point on the curve. We're going to call this like x1, y1, right? Just some point on the curve. So this corresponds to x1 here, and over here corresponds to y1, right? So then say we consider a second point on the curve, right? So let's just copy. Come on. Are you lagging on me, Pace? All right, we consider a second point. The second point is going to have its own x2 and y2 that correspond to it, right? Let's make it like this color or whatever, right? So there's going to be an x2 and a y2 that correspond to that second point on the curve, right? So then what we're doing is basically we're taking x1 and we're adding just some positive distance, or we're adding some distance to it to generate this x2. And then as that change in x gets closer, gets smaller and smaller and smaller, this second point gets closer and closer to the first, right? That's what the h is. So the h is just some change in x, right? So as h goes to 0, the second point gets closer and closer to the first. And so what we're considering is the secant line that passes through these 2 points, right? So there's going to be some line that passes through these 2 points. So as that second point gets closer and closer to the first, then this line is going to become closer and closer and closer to being like a tangent line, right? It goes from being secant, and as that second point gets closer and closer to the first, we get a better and better approximation for the slope of this tangent line. That essentially is what the derivative is, right? The derivative is the slope of a tangent line at a point. That's about as clear, as concise explanation as I can give. I think I lost my window, so I'm going to have to try to bring it back. Okay, there's that one. Let me see. Yeah, it looks like it's gone. So we were working section 1.5, which is here. And we're going to start with question number 1. So the difference quotient definition, that comes out of college algebra. But so what we're going to look at today are some shortcuts. Instead of doing all of that algebra, we actually have some shortcuts where you can actually just look at it and you'll get the result fairly quickly. Is that still working? It looks like it's still working. So what I'm going to do, let's go here, and I want this like this. Let's check one more thing back here. Okay, it looks okay. That's exactly what I wanted. Okay, so let's hop over let's hop over to and I know I still need to make all these notes available. Go down and try to make it a point to get that finished updating before I do other things for the night. Okay, so let's take some time to walk through as many of these as we can. Let me just, I'm going to kind of skip this. This is a college algebra review for this question, so just for the sake of time, I'm going to skip that. During class, if you have a specific question, we can go back to other sections. You know, if you want me to kind of go through a question during class, just stop me and we can go through it. I'm gonna this is a college algebra question. I'm gonna skip that. I want to kind of get into where we are today. Okay, let's try this one. It says use the theorem on limits of rational functions to find the limit. If necessary, state that the limit does not exist. So we have the limit as x approaches -4. So for the limit to exist, the limit on the left has to exist, the limit on the right has to exist, and they have to be the same number, right? So something like this, they probably, like for instance, it looks like we can actually just plug in the -4 here, right? Because if we just plug in the -4, that's going to be 16 minus 5. What is that, 11? And that's going to be 4 plus 4 is 8. So it looks like it's 11 over 8. There's nothing fishy going on. So I'm just going to try 11 over 8 for now. Okay. Okay, let's try the next one. The initial substitution x equals a yields the indeterminate form, right? Simplify the function algebraically or use a table and graph to determine the limit, right? So we have a couple of techniques that we have for evaluating limits. We could either simplify it algebraically, and we'll try that first. And if we can't get it that way, then we can use either a table or a graph to determine the limit. So this one I'm going to take some notes. We got the limit as x approaches 4 of this. Now I think if we just plug in 4, we're going to get 0 over 0. So that's not going to work on this one, right? So let's walk through this one. Let me start by taking some notes. Okay. Let's take some notes. So this is question number, this comes from section 1.5, Leibniz notation. And what is it? Power and some difference rule. Power and some difference rules. Okay. All right. So this is question number 4. This comes from section 1.2, question 21. That's okay. So that's kind of going back to limits, but that's okay. So we have this limit as x goes to 4. Now on top we have x squared plus 3x minus 28 over, I'm just taking notes, I know you can't see it. I'm about to hop over there in a moment. X squared minus 16. Okay. So basically evaluate the limit. Let's hop over to the tablet, which is going to be here. Boom, looking good. Okay. And I'm going to get rid of this for now. Okay. So again, if we try to just plug in the 4, we get 0 over 0, so we can't do that. So what we're going to do is simplify the quotient first and then see if we can just plug in, right? So then this is going to be equal to the limit as x goes to 4. Now, it looks like the top can be factored, right? My goal is to factor it into some form like this. And something similar on bottom, right? So x and x, so this comes from before college algebra, actually, factoring, right? Two numbers that multiply to give me 28. Let me see, one is going to be positive, one is going to be negative. What is it, 7 and 4? A positive 7 and a negative 4? Let me check really quick. So then 7 times negative 4 is a negative 28. 7 minus 4 is a positive 3. Okay, so that checks out. And then on bottom, it looks like we have difference of squares. We have something squared minus something squared. So that's going to be x minus 4 times x plus 4. Okay. So now after doing this, now we can see that some terms cancel. So this cancels this. So now this is not the value of the function at that point per se. This is just what we're doing is we're getting a sense of how the function behaves when we're close to x equals 4. Right? Because if, again, in the original, this function is not defined at 4, but we can get a sense of what happens when we're close to x equals 4. Okay, so if we keep going, let's be consistent. So this is going to be the limit as x approaches 4. We're going to have x plus 7 over x plus 4. Okay. So now, oh, and that's not a 4. So now, if we just plug in the x, 7 and 4 is going to be 11 over 8. Oh, is that the same thing? Huh. Anyway. Okay. So we get 11 over 8 there. Okay. So let's see, how do we do? That's fine. Hop back over to Pearson. Go ahead. Let's see. I plugged in. So once we did our cancellation, then I tried plugging in again, and we were able to evaluate the limit that way. We don't always have that as an option, but we try it first. Yeah. Okay, that was good. So that one was good. We're gonna go on to the next one. Okay. Yeah, we can do this one. Why is it doing a lot? It's doing a lot of 1.2, but that's okay. So I kind of wanted to get to the shortcuts, but that's okay. Let's see. So that was 4. Let's do this one. So this is number what? 5. This is kind of in my way. So question number 5. This comes from section 1-2, question 36. Okay. Determine the limit. So we have the limit as x goes to positive infinity. So x goes way off to the right. What happens, right? Oh, I like this one. This one's much easier. At least I think it is. That's what I'm anticipating. 42x cubed plus 2x squared minus 3x over 12x cubed plus x squared plus 3x plus 3. Okay. Let me do this real quick. All right. Oh, and let's hop over to the tablet so you guys can see, people at home can see what I'm writing. Okay. Basically, I'm just going to evaluate the limit. So something like this, we're saying, okay, what happens, how does this function behave as x goes way off to the right? If we were looking at this graph, this is like, as x goes off to positive infinity, way off to the right, how does the function behave? So what we're going to do, we're going to take the largest power of x, in this case is going to be x cubed, and we are going to, I'm going to factor out x cubed from all the terms, right? So if we do this, like, so let me see, we're going to get this. This is going to be equal to the limit as x goes to infinity. Now, if we factor out, I'm going to factor out x cubed. I'm going to factor out 1 in this form, and we're going to factor out x cubed from the top and the bottom, right? So on top, that's going to give us 42 is going to be left. Then we're going to have 2 over x. Let me think about it. Yeah, that's good. And then minus 3 over x squared. So basically, I just divided every term. I factored out the x cubed, right? And divided everything by x cubed, right? And then on bottom, we're gonna be left with, if we take out x cubed from all of those, or divide everything by x cubed, we're gonna be left with 12 plus 1 over x plus 3 over x squared plus 3 over x cubed, right? So we just factored out. So no, something divided by itself, this all essentially just goes to 1. So now when we try to pass the limit, because I think if we try to take it to, if we had let x go to infinity in the beginning, like here, then we would have got like infinity over infinity. But now if we let x go to infinity, so as the denominator gets bigger and bigger and bigger, the numerators are fixed. I'm about to let this student in. This term essentially goes to 0. This goes to 0. This goes to 0. All of these terms go to 0. As x goes way off to the right, they essentially go away. They essentially go to 0. So then as x goes to infinity, what we're going to be left with is 42 over 12. What is that? 21 over 6, which is what? 7 over 2. 6. We can divide both of those by 6, right? Okay, let's see how do we do, and then we'll let this student in. Oh, come on. That's a pain. Anyway, let's see, how do we do? So we got 7 over 2. Let me see, who is this? Did he get attendance already? I think he was here because I know some people. No, he hasn't. Okay. Go ahead and let him in. We got 7/2. We're going to hop over here and let's see how do we do. 7/2. Okay. I don't think there's any questions in the chat. So the trick there was the whole dividing out or factoring out the highest the variable with the highest exponent, right? Some of the stuff you wouldn't naturally think this way, but once you see it and you know that's there, then you can add it to your bag of tricks or whatever. Okay. You good? It's okay. All of these terms essentially go to 0, right? Yeah, they go. Yeah, the ones that I crossed out go to 0. Yeah, that's a good question. Okay, let's hop back so people can see. Are you all able to hear each other's questions? Like when other people get on, can you guys hear? Okay. Okay. And hey, we're all here to learn and grow. You know. Now the other thing is I don't know that if YouTube can hear what you guys are asking. I don't know. I had to go and check and watch those videos, but I really don't ever watch them. I just, I don't allow shade. Don't worry about that. I don't let people throw shade. But it's whatever. Because it's like we're here because we don't know. Like if we knew all this stuff, Anyway, that's beside the point. The chats, they're ready. I know. I know. It was clear. Okay, let's see. What's the next one? Use the limit properties to find the limit if it exists. Okay, so it's x. So this was a similar one. Maybe we can do this one a little bit faster. I think the answer is going to be 4. If we divide by x cubed, that goes to 0. 16 divided by 4. Does that work? Let me think about that. Let me back up. I think it's actually going to go to 0. This one should be 0. This is kind of a repeat of the last one. If you do the same technique that we just did, I think the answer is going to be 0. Let me see. Okay. If I need to write that out, let me know. But it should be the same thing that we just did with different numbers. But if you do the same thing, you'll see it. All right. Because I'm trying to get to... kind of want to get to, let me see, the limit is x goes to 2. So what happens if we just plug in 2? What is that? 9 times 2 is what, 18? Oh, wait a minute. Let me think about it. 9 times 2 is 18 minus 7. What is that, 11? The square root of 11? I'm just going to put, this one I just plugged in. Let me try square root of 11. See what happens. Okay. So we got fortunate there. I was about to launch into some other stuff, but I was like, let me just try to keep this as simple as possible. Okay. Find the derivative. Okay. So this is what I was really trying to get to. So this is going to be the first. This is like the power rule. So in the previous section, to evaluate this derivative, we were doing things like the limit as h goes to 0 of the difference quotient of this, and it was this long drawn out algebra, right? So the power rule, all that work that we were doing with the difference quotient, we can do it in a split second like this, right? The power rule basically says if this derivative exists, what you can do is basically bring the exponent down and subtract 1 from the exponent for this one, right? That's the power rule. So the answer here, instead of doing all that difference quotient and the limit as h goes to 0 and all that jazz, you can just say 3x squared and then you're done. So this is the first property, is the exponent comes down and you subtract 1 from the exponent. All of that stuff is laid out in my lecture. You don't have to watch it. I would recommend watch it. Take notes as if you're in class. Okay, that's where I go through more details. But you can essentially get it from here as well. So dy by dx is that might be the Leibniz. I don't want to say that incorrectly, but this is another way that we articulate derivative. So when you see dy by dx, this is like the derivative with respect to x of y, or of whatever the function is, right? So this is just another way to articulate derivative. Notice that there's no x here, right? So this is a constant. Another property is that the derivative of a constant, So this constant could be written the same as -2 times x to the power of 0, right? A constant is the same as 2x to the power of 0, right? So if we apply that same power rule, if you have x to the power of 0, that 0 comes in front. Long story short, the derivative of a constant is going to be 0. Okay? All right. Let's go to the next question. Power rule still, right? So we're just going to bring the exponent down and multiply, and then subtract 1 from the exponent. So then 4 times 3 is -12x, and then if we subtract 1 from the exponent, that's going to become -4. And I'm just going to go with that. So much easier. Like now, if we had tried to use limit definition, the limit definition of the difference quotient, it would have been this long, drawn-out algebra. Your brain is like mush. But with these power rules, with these different like shortcuts, this is when I was really like in love with math. I was like, oh, this is so easy. I could do this all day. And like to me, this topic of differentiation, this is like half of what calculus is about. So again, the derivative of a function tells us the slope of the tangent line at a point. So then suppose we're given the slope of a tangent line at a point, how can we work backwards? To me, that's called integration. That's the other major part of calculus, is working backwards. So integration is the reverse of differentiation. That's coming down the line. We'll get to that as it arises. So we're asked to differentiate. Let me write this one out. Because it's a little bit different, but not really. So this is question number 11. This comes from section 1.5, question 21. It just basically says, I'm just going to write differentiate. Okay. We have y equals is 14 times the square root of x. Okay. Let me hop over to the tablet. Boom. Okay. So we can essentially do what we've been doing, the same thing we've been doing all day, but we need to put it in the proper form. Square root of x is the same as, it's going to be the same as 14 times x to the power of 1/2. So square root of x is the same as x to the 1/2, right? So then we do the same thing. We bring the power in front and we subtract 1 from the exponent, right? So if we do this, we're going to say y prime, that's fine. It's going to be 1/2 times 14 times x. 1/2 minus 1 is a -1/2. So then we just need to get it into the proper form. That's going to be 7x. Right now I'm going to leave it as x to the -1/2. Let's see if they accept it. If they don't accept it, we have some other forms we can put it in. Okay, let's see how we're doing. D by dx, that's okay. So this is the derivative with respect to x of this function. Again, this is where the derivative, let me see if I can. This is where the derivative with respect to x, 10 minutes, okay. I will, so we'll go for another 10 minutes on this section. I think I'm gonna actually just keep going. But in 10 minutes, I'm gonna have to like get off the Zoom call. I'm gonna end the meeting and I'm gonna get right back on and you can just come right back in, okay. So first I'm gonna do 7x to the -1/2 and see if they accept it. 7x, oh, right here. 7x to the power, I'm gonna put -1/2 and see if they accept it, okay. Because there's more that you could do there, but this is fine for now. Okay, let's try another one. So find the derivative. Okay, let me write this one out. So this is number 12. It says find dy by dx. And we have y equals 20 divided by x to the 4. Okay, let me show my notes. Okay. I could do that, but that's okay. Okay, so first I'm going to rewrite this. This is going to be the same as 20 times x to the power of -4. Then, once we have that, we can do the same technique, right? The exponent comes down and subtract 1 from the exponent. So then dy by dx, what is that? 4 times 2 is going to be a -80x to the power of -5. go here. Okay. See, how do? We want to hop here. And we got a result of negative 80x to the power of negative 5. Okay. Looks good. On to the next one. Okay, we can do the same thing here. I know it looks intimidating, but it's the same thing. It's actually just a repeat. You good. Coefficient. Yeah. Yeah, when we bring it in front, we do multiply. Yep. Okay, so this one is d by dx. We got the cube root of x minus 8 over x. Okay, let me show. This comes from, let me be thorough with my notes or be consistent. This comes from section 1.5, question 29. Okay, let's hop over. Maybe I can just do like this. Let me see. I think that worked. Yeah, it usually does. Okay. And actually, just for my own thing, I'm going to move this to like here. Okay. So let's do the same technique, right? We've been writing them all as power functions and then applying the technique. So this is going to be the same as d by dx of, that's going to be what? Cube root of x is the same as x to the power of a third. That's going to be minus 8x to the power of negative 1. Okay. So then when we apply the technique, same thing, comes down, minus 1. Comes down, minus 1. Okay. So then that's going to be 1/3 x. Let me see. 1/3 minus 3/3 is going to be a negative 2/3. Double negative becomes plus 8x to the minus 2. Okay, let's go with this. Let's see if it works. Gonna put this in Pearson. See if I get it right. Oh, okay, looking good. Find the derivative. Okay, let's give it a go. 1/3 x to the power of a negative 2/3. Okay. Looks good. Plus 8x to the negative 2. Okay. Let's keep it going. Let me see my time. 5 minutes. Let's keep going. Sum and difference. Well, I think we're good, actually. Okay, notice. So the exponent on the x here is a 1. So the 1 comes down, then we're going to have x to the power of 0. That's going to leave us with just 7 over 8. Okay. Let me see. So we got 1/2. I don't want to write it out. It's going to be what? 9 over 16 times x to the power of 1 over 8. Same deal. Exponent comes down. So this is the same as 1/2 times x to the power of 9 over 8. So the 9/8s come down. So that's going to be 9 over 16. 9 over 16 x to the power of, I think it's 1 over 8. Okay. Is these all of these are the same. It's just it's different forms, but it's the same thing over and over and over. So far for all of these. Let me see if I can do this one quick. Okay, if the exponent comes down, that's going to be negative 21 over 2. Let me see, negative 21 over, nope, that's not 21. Negative 21 over 2 x. Let me see, a negative 3/2 minus 2/2 is a negative 5/2. So to the power of negative 5/2, okay. Negative half times 2 is going to be minus 1. It's going to be x to the negative 3/2. So to the power, I'm just not writing it out for the sake of time. That's going to be plus 8x to the power of 7. Power of 7. Okay. And then derivative of a constant is 0. So I'm going to go with this. Oh, because if that was wrong, I was like, oh, I had to go back over all of that. And then I would probably feel inclined to write it out. If I need to, just let me know. Let me see. Let me see what's next. So we got about halfway through this. Okay, I think you can handle that. Okay, I'm gonna go ahead and end the Zoom call, and I'm gonna just log right back in, and just you can come right back on in. Yeah, I'll be right back because we only got like 2 minutes left. I'll be right back. Okay. So I'll let people in as they arrive. Okay. I actually some indifference. I think we're actually okay. So I think I'm actually going to close this out and hop over to section 1.6 because I want. Go ahead. Hmm. Hmm. Yeah, I have to like figure that out. I was just using what I already had ready to go. Yeah, thank you for that because I figured they would because I know they do have that kind of stuff. So I had to follow up on that next time. Thank you for that. Let me hop over to section 1.6. Let me hop over to 1.6 because I feel like most of that's going to kind of be the same, and I kind of do want to talk about 1.6. So let's see, it's going to be here. I will be right there. I got to turn the AC on. Oh, and I got to load some more assignments. So we're going to open this up. Ooh, I'm about to start sweating. Feels kind of good though. All right, and then we need to do like this, and it is right here. Okay, and then like that and like this. That looks good. Okay, let me check one other thing. That looks good. Okay, so for the second half of class today, I do want to let's go ahead and get started on section 1.6. I want to say the remaining of those questions for 1.5 were similar, you know, so I'm going to let them be. So this is the product and quotient rule. So we saw Leibniz notation. Let me see. Yeah, he was already in there. Leibniz notation, and we saw the sum and difference rules, right? So you can essentially like pass the derivative through. You know, we saw it in action. Did he get attendance credit earlier? L. Ooh, okay. That's okay. I'll let him in. Okay. So let's start with this. So this still comes from section 1.5 and it acts as the find derivative. So again, the power rule, again, the exponent just comes down. That's going to become negative 2x, and then you subtract 1. So it's going to become up to the power of negative 3. All right. So again, for the power rule, what we were saying, the exponent comes down, and then we subtract 1 from the exponent, and that's the derivative. So instead of doing all the limit definition of the difference quotient, we can do this. Scott form. Okay. At least one. I kind of want to use a calculator. I don't don't feel like doing it at all. I'm just going to use my calculator. Let me see. I'm just trying to find an easy calculator that I could use. I think there's one here. What is... I want to do 8.5 divided by 5. Okay, 1.7. Okay, so if we do the same thing, exponent comes down, 8.5 divided by 5, so it should be a negative 1.7 times x to the power of 1 over 5 minus 5 over 5 is a negative 4 over 5. Okay, this should be okay. Okay, on to the next one. What's the time? We're doing good on time. Okay, let me write this one out. This is still kind of a repeat, so I'm glad I did come on to this section. Let's see. So this is question number. Oh, this comes from section 1.6, the product and quotient rule. So the product, and quotient rules. Give me just a moment. Get all this on one line. So what I'm using to take notes, I'm using this app on the iPad called Notability. I really like. It's just shameless like marketing for them, but I've used it for years. I've been using this app since 2009 when I was 2009 when I was in grad school. Where was it? There that I used this? Yeah, I think it was there. But I've been using it for a long time. It works great, and they're always updating it. Like I really enjoy it. Anyway. This is question number 3. It comes from section 1.5, question 31. Find the derivative of the given function. Okay, so unstable. Well, we're going to have to do the best that we can. Can't worry about it. Find the derivative. I'm just going to say find the derivative. Okay. We're given this y equals the 4th root of 9x. Now this is kind of a repeat of what we've been doing. I just felt like I can see this one better if I write it down. Let me close this out. Let's hop over here. Okay. Find the derivative. Okay. So we're asked to find dy by dx. So before I do that, let me write this in the proper form, right? The 4th root is the same as this thing to the power of 1 over 4, right? So now when we go to take the derivative, when we go to find dy by dx, the 1/4 comes down. It's going to be times the 9, the x. 1/4 minus 4/4 is a negative 3/4. Okay? So then ultimately that's going to be 9 over 4 x to the negative 3/4. Okay. So we're going to hop over here. That looks good. We got 9 over 4 x to the power of a negative 3 over 4. Okay. Let me think about it. 4th root. The 1 over 4 comes down. Oh. I see what I did wrong. Yeah. I see what I did wrong. Okay. So what I did wrong, I passed the 1/4 through the radical, right? So we still have the 1/4, but that needs to stay outside the radical. So this 9x still needs to be inside the radical. Yeah, the negative 3/4 applies to, so yeah, my parentheses, I had messed up my parentheses there. So it needs to be like this. Okay, I think that's better. Let me see, can we simplify that? I'm gonna try this first and go with this and let's see what happens. Okay, wait. Yeah. I got to think about here. I might let me try. I got one more attempt. Give me a second. Let me think. Only other thing I could think, fourth root, cube root. Okay, let me see. If we have, okay. Let me write it out. So let me not rush so much. I might get it wrong. We'll fix it. But let me do one other thing. So let's do this. So I did make the adjustment. You can see it there a little bit. So here, let's get rid of this guy. And I changed. Let me highlight the change that I did. So I did move this parenthesis that you see in red. I did move that one. But now we need to account for the change. We got to think about this. So let me, the thing in question is the following. 9y by dx. The 1, 4, I'm confident in that, right? Now we can do the following because there's no addition and subtraction. We're going to have this 9 to the power of a negative 3/4. That's the guy that I think is giving us a hard time. And then I'm going to leave this x to the power of negative 3/4. Okay, so it's that 9 to the negative 3/4 that we need to address. Fourth root, right? Okay, so I'm going to do that off to the side. 9 to the power of a negative 3/4. That's the same as 1 over, that's what, the fourth root? So let's do the fourth root. Basically 9 times 9 times 9. 999, right? That's what it is. Because it's 9 cubed. But then this is the same as the fourth root. That's going to be 1, 2, 3, 4, 5. It's 6 threes, right? It's 6 threes. Because if it's 3 nines, that means we have 6 threes. So then we gotta account for groups of 4. So for instance, here's one group of 4 that we do need to account for. That's 3 to the power of 4. So then that becomes just a 3 on the outside. Okay. So then we're going to have 3 times the fourth root of 9. That's all in the denominator. Okay. I think this is okay. And then it's this thing times 1/4. So now if we put it back, we're going to have dy by dx equals 1 over 4. We got this 1 over 3 times the fourth root of 9. Okay. Okay. And let me do like this. Okay. And then the thing that persists is that x to the negative 3/4. Okay, so now we need to simplify that thing that we have. I'm just trying to think of the simplest way. We can do that as 1 over 12. We can do that as 1 over 12. The fourth root of 9, 9 to the 1/4. So I'm going to write that. I'm just trying to think about how I want to write it. Okay, we can leave it as the fourth root of 9. We'll just leave it there. Hopefully they'll accept that, and we're going to figure out what we're going to do, how to get it right. X to the negative 3/4. Okay. I'm going to try this and see if they accept it. Let me think about it. We could do 9 to the negative 1/4, but I'm trying to be consistent. Let me look at one other thing before I do it, before I submit this answer. So because I'm a little bit unsure, what I'm going to do, I'm going to click on the question help, and I'm going to click on the view an example, right? So here's one that's similar. Cube root, this is fine. So you can see that the thing that I did wrong, the 7x, we accounted for that already. The derivative of a constant, yep, we did all that. Let's keep going, continue. Oh, I see what I did wrong. I totally did take the derivative of a constant. Yeah, I'm just wrong across the board. I see what I did. Okay, I'm going to start this one over. I'm going to try it one more time though. So the one thing I can see that they did different, they went on and separated the constant from the variable first and then take the derivative. I took the derivative without separating the constant. Okay, so let me separate this constant right here and then take the derivative. Okay, so I'm going to scrap my work that I did earlier because I don't know, I just didn't get it. So I'm just going to scrap it. I'm going to erase it. I'm going to keep that. I'm going to get rid of all of this. delete. Okay. So let's go back and try it again. I see what I was, at least I think I see. Let's just try it again. Okay. So, and I'll try to make a copy of these available. So here's the original, right? And we rewrote it as 9x to the power of 1/4. Now, what we're going to do different, we're just going to separate the constant, right? And that'll help out with a lot of that stuff. So then this is going to be the same as y equals 9 to the power of 1/4 times x to the power of 1/4. So then when we go to do dy by dx, the constant, you can actually just multiply the constant times the term. So that 9 to the 1/4 just persists. And then this other 1/4 comes down, and we're going to have x to the negative 3/4. Okay. So we get 9 to the 1/4 over 4. All right, I'm going to try this. I'm going to try this one. All right. Let's hop here. Let me see how they put their final answer as well. That kind of helps too. So they put theirs in the form of, let me see. We got that 4x to the 3/4, and they moved it to the bottom. Okay. So I'm gonna put mine in a similar form. And we were almost there, but I'm not gonna worry about that. Okay. So on top, let me do my fraction. We got 9 to the power of 1/4. That looks good. On bottom, we have 4 times x to the power of 3/4. I think this is okay. All right. This is it. Moment of truth. Whew. That was a journey. What an adventure. That was an adventure. But that's how these things go. Like, you get it wrong, you're like, okay, well, what did I do wrong? It's not about, it's just about, rolling with the punches and adjusting. Like how well are you able to adjust? I'm definitely going to write this one out. Let's give this one a go, right? So this is question number 4. This comes from section 1548. It just says differentiate, okay? We have this y equals, we got x over 11 minus 11 over x. Okay, I feel like this one isn't going to be that bad, but you don't really know until you're going to do it. Okay, this is fine. Let's hop over to the tablet. Actually, I'm going to try some shortcuts like that. I just want to check. It looks like it worked. Okay. Yeah, I'm going to let that be. Okay. So, differentiate, right? So first, let me put it into a similar form like what we've been doing. So we're going to have y equals, this first thing is 1 over 11 times x. That one's fine. This one is going to be minus 11x to the minus 1. Let me think about it. When does that come into play? Is that here? I don't think that's here. Okay, let's go with this, and let's take the derivative. So if we do dy by dx, that's going to be, so the exponent here, there's an implied 1, right? So 1 over, if we do the same technique, that should just become 1 over 11. The second one, if we say the exponent comes down and we subtract 1, that's going to become plus 11x to the minus 2. Okay. I'm going to go with this. And let's see how do we do. All right. Oh, and let me just do it here. That should be good. Okay. Let's see how do we do. So we got 1 over 11 plus 11x to the power of minus 2. All right. I think the chat is okay. I'm going to keep it moving. Let me go ahead and close this out, because not this, I'm just talking about another window I got for the attendance. Give me just a moment, guys. I'll be right back. How do I mark? Do I have to modify? Mark all? No. Let's just do it like this. All right, I'm not going to worry about that. go back. Oh, that's in previous. Oh, absent. Make sure I got it from today as well. Okay. All right. I'm just gonna go fully like this. Come on. What's the time? I see the time. We'll hang out for, if we get out at 7:15, I don't want to go past 7:10. Okay. I usually stop about 5 minutes earlier, so. All right. So I think we did that. Let's go on to the next one. So use the product rule to find the derivative of a given function. Find the derivative by multiplying the first. Oh, product rule. First, okay. Yeah, let me write this one out. So now we're getting into the product rule. So this is what I've been looking for. So far we've just really been doing the power rule and the sum and difference rule, right? So the product rule. So this is question number 5. This comes from section 1.6. This is question number 1. So I'm just going to say use the product rule, use product rule, okay? And then find the derivative of multiplying the expressions first. Okay. B. Find the derivative by multiplying the expressions first. Okay. And we have this y equals x to the 6 times x to the 7. Okay. Let's hop over to the tablet like this. Should have worked. Okay. All right. So first, we're going to use the product rule. Now, this is the first time that we're doing the product rule together. I did mention it in my lecture, so let's just I'm just going to say it. So the product rule, when we go to take the derivative, when we take the derivative of a product, we're going to say the first times the derivative of the second plus the second times the derivative of the first. Let me say that one more time. The derivative of a product is going to be the first times the derivative of the second plus the second times the derivative of the first. Okay? So when we go to find dy by dx, the first is going to be x to the 6 times, let me do it like this, times the derivative, or d by dx, of the second. So it's the first times the derivative of the second plus the second times the derivative of the first, right? Okay, so if we actually do it, that's going to be x to the 6. So then if we take the derivative of the second, that's going to be 7x to the 6 plus x to the 7 times 6x to the 5th. Okay? Let's see what happens. Let me think about it. So we add the exponents, right? So that's going to be what? X to the 12? 7x to the 12 plus 6x to the 12, and we get 12, 13, 13x to the 12. Okay. That's interesting. And the reason I'm saying that's interesting, because that's what we got when we use the product rule. All right? Oh, come on. Why are you behaving like that? Okay, whatever. Okay. So that was a demo on the product rule. So then the second part, so that was part A. The second part asks us to find the derivative by multiplying the expressions first. So then if we're doing B, if we have y equals x to the 6 times x to the 7, that's going to be x to the 13. So then dy by dx is going to be 13x to the 12. Okay, so we got the same thing. That's why I thought it was interesting, because I wasn't really sure what was going to happen. Style like this. Okay. So we got the same thing in either case. I'm watching the clock, no more than 10 minutes. Let's hop here. Okay. You use the product rule to find a derivative of a function. The first has a derivative of the second. X to the 7. 6x to the 5th. Where is it? I'm looking for it. Let me see. X to the, here it is. X to the 6, 7x to the 6, plus x to the 7. Okay, right here. Let's do this one. So we got 7x to the power of 6. And then here we got 6x to the power of 5. 6x to the power of 5. Okay, I think that one looks good. And then multiplying the expressions, find the derivative by multiplying. Okay, so this is going to be x. This should be x to the 13. And then the final, we got 13x to the 12. Okay, let's do another one. From B, okay. Come on, little thing. So we're multiplying two expressions of the same base. We got x to the power of 6 and x to the power of 7. So when we multiply the same base, we add the exponents. So 6 plus 7 gave us a 13. And then once we had x to the 13 and we take the derivative of this guy, then the 13 comes down and subtract 1. Yeah. My pleasure. All right. I think we're good there. So let's go into the next one. Let me see. We got 10 solid minutes. So again, I know we're about out of time here, but like as you're working through this on your own, if you get stuck or need help, click on the Ask My Instructor again. As long as I'm not like busy or distracted or whatever, I'll make a if I don't respond to your video by the next time we meet, just ask me during class, and we can talk about any questions that you want during class as well. Let's do the next one. Product rule. Why are they opening it up like this? Okay, but that's okay. I actually want you to see the quotient rule. Let me try to find one that has the quotient rule. So that's another product rule one. We'll come back and do some more of these, but I definitely want to show you the quotient rule. We could do this one. Let me see if the next one's a little bit lighter. It's not. Let me do this one first. I'm trying to introduce the quotient rule together. So this is question number 8. We got like 10 minutes. We're watching the clock. This comes from section 1.6, question 13. Part A says use the quotient rule. Part B, divide the expressions first. Find the derivative by dividing the expressions first. I am kind of using chicken scratch notation. I'm just trying to get a copy of it. I know I can screenshot, but that slows me down too much to do that sometimes. All right, we're going to say y equals, we got this x to the power of 8 over x to the power of 6 for x not equal to 0. So they just put that disclaimer in to be complete because, we cannot divide by 0. Let's hop over to the tablet. I want to make sure we're showing. Okay, looks good. Okay. So the quotient rule. So the product rule, the way that one went, product rule goes first times the derivative of the second plus the second times the derivative of the first. So then when we go to do the quotient rule, the way I remember quotient rule is like, okay, it's basically the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. In other words, the way I remember that, low D high minus high D low over low low. Okay, let's see what I mean by that. So again, all right, so for part A, I'm going to write it a certain way, but the way I remember it, low D high minus high D low over low low, okay? I know it looks weird, but that's how I remember it, right? And so what that means is the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared, okay? So let me see. So if we're going to find dy by dx, low, which is the bottom, times d by dx times the derivative of the top is going to be the 8 to the x, minus the top times the derivative of the bottom all over the bottom squared. Okay, that's the quotient rule. Bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Or you can remember it as low d high minus high d low over low low. Okay. So now if we evaluate or simplify, okay, so that's going to be x to the 6. If we take the derivative there, that's going to be 8x to the 7 minus x to the 8 times 6x to the 5th over 6 times 2 is 12. So that's x to the 12. Okay? We don't need parentheses there. And if we simplify, so 6 is 12, 13. So 8x to the 13 minus 6x to the 13. Okay, we just got lucky. Over x to the 12. But we can subtract those because they're the same. Those are like terms, the same variable with the same power. So 8 minus 6 is 2. That's going to be 2x to the 13 over x to the 12. And then we can take that a step further. We can subtract because they have the same base. So it's just going to be 2x. Well, looky there. It does not generally work out nice like that all the time. Hopefully we did it right. Okay. So we're going to let that be. And then part B asks us to divide the expressions first, okay? So part B, if we have y equals x to the 8 over x to the 6, but then that's going to be the same as if we divide, it's going to be x squared. Yep. So then when we're going to do dy by dx, that's just going to be 2x, which is the same thing we got. So we could have simplified it first and then found the derivative. Okay. Oh, 10 minutes. Man, they are just serious about our time. Okay. Let's hop back over to Pearson. Okay. So for the first one, we got x to the 6. So it should be, what's the difference between these? It should be the first one, right? X to the 6, the second part was 8x to the 7. 8x to the power, to the power of 7 minus x to the 8, 6x to the power of 5. 6x to the power of 5, okay? Okay, fantastic. So then if we divide, we got x squared, okay? And then finally, in either case, we finish with 2x. All right, let me see. All right, we'll let the next one be the last one. Differentiate the function. Okay, so yeah, this is quick. Well, it's not that quick, but low d high minus high d low over low low. So the low, so it has to be either A, B. It could be. It just can't be B, right? Low d high. So let me see. The derivative of the top. Derivative of the top. So it could still be any of them. Minus high d low. What's the difference between these guys? Is it the bottom? Okay, so it looks like it's either, it can't be A because the bottom isn't being squared. It's not B. Oh, and my headphones are losing power too. Man, everything is just like shutting down on me. That sound, you know, the sound when your AirPods are like losing power, it goes doo 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 doo. It always like scares me because I don't be expecting it. It's not A, it's not B. I think we said it's not D because that's not applying the technique proper. So by a process of elimination, it should be C. Low D high minus high D low over low low. Okay, I'm gonna go with that. And I said I was gonna make this the last one. Oh, okay, so simplify. Ugh, I don't feel like writing that all the way out. Let me see, that's gonna be 6x. That's gonna be 24x. Yeah, I don't feel like doing any of that. It might take me some time. Let me see, 6x, because I would need to distribute. I'm trying to do it quick, and I can't see it. 6 times 5 is what, 30? I'm gonna. We got time. Let me not do that. Let me finish. Let me try at least. We still got a solid 2 minutes. I'm just gonna do it on my own off to the side. Or if somebody wants to give me the answer, if somebody thinks they have the answer that they want to try, we can do that too. Okay, but I'm just gonna do some quick notes off to the side on my own and evaluate that numerator. So here, let's do like this. This is question. I'm not gonna write everything. This is just question number 9. This comes from 1-6-23. Okay, I'm gonna say set up and solve. Set up and solve. Okay. And I'm just kind of trying to finish this out. So we got 8x cubed plus 5. Now if I take that derivative, that's going to be just 6x because the derivative constant is 0 minus the second part, 3x squared minus 4 times, that's going to be 24x, okay? I'm going to go ahead and write over 8x cubed plus 5 quantity squared, okay? I'm watching the clock. I think we're about to get out of here. Let me hop over to the tablet. Okay, I'm assuming that you guys can see it on YouTube. Okay. Oh, so we can distribute, right? I just want to do a distribute there. We're going to distribute a negative 24 here. Okay, let's see if we can catch those changes. What is that? 48x to the 4, 30x. 75 minus 3, 72. So I'm going to say negative 72x cubed. That's going to be plus 40. 4 times 2 is 80 plus 16. I think it's going to be a 96. 96x. That looks good. Can we factor? Are there any like terms? Nothing similar. Okay. Nothing seems like it cancels. Okay, so before I submit this answer, I was really just trying to get that numerator. I'm going to see how did they submit their answer. That's what I'm going to look at. And then, we're going to try to get this right. I'm going to go click on question help. Oh, they don't have a V1 example. Dang. All right, so we're kind of on our own with this one. So, okay, we're just going to try it. The derivative. Okay, I'm trying to think if there's anything else. Squared. Okay. It just looks like a lot. Nothing we can factor. Okay, I'm just going to go with it. All right, so this is going to be it, because if we don't get it here, I'm probably just not going to try anymore. 48x to the power 4, 30x, 72, x to the power of 3, 96. 96x, and then the bottom. Because sometimes you can simplify these, and you have to think about it some more. X to the power of 3. What's my time? 2 minutes there, and we're fine there. I'm about to let you go. 8x cubed plus 5 quantity squared. All right. Cross our fingers. Darn it. Let me look at it. We got a few more minutes. Let me look at it. I got at least 2 minutes here on Zoom. What else could I do? We could factor. We probably could factor some stuff. We could factor out something. Because everything at least is divisible by 2x. Oh, like terms. There we go. 120, 126. Okay, let me at least combine those. 126. Oh, I think that's good. Let's do 126 here. Okay. We can still factor out some more, but I'm going to go with this. Let me think about it. Squared. We factor out an x. That's not going to do anything. All right. The only other thing I can think of the numbers. I'm just going to see the answer just because I'm kind of out of time and that's trying to rush. I'm just going to submit it. Negative 24x x 30. Your answer 96. Are we missing some negatives? Double negative is positive. 90. So just trying to rush. Okay, well, we can try it again another time. We're close. It's just algebra, and just try not to rush. I'm not going to worry about it right this second. Not too much. Anyway, we're almost out of time, so I was just trying to rush. Okay, so I'm going to let that be. So fortunately, we had to end it like that, but it ends like that sometimes. But we're going to end the session here, okay? If there aren't any other burning questions, I'm going to let you guys go. And from one beautiful mind to another, enjoy the rest of your day. Okay, guys, take care. My pleasure. See you. Take care. See you next time. Let me go ahead and quit this. Bye-bye.